All right, boys and girls, Algebra 2, we're looking at section 5.2, example 4. It says to use the discriminant to determine how many solution types there are and then use the quadratic formula to find them. Okay, so recall the discriminant is just the radicand in the quadratic formula. It's the b squared minus 4ac. And it's really pretty easy to think about. If your discriminant is a negative number, you're going to be taking the square root of a negative number, which is no good. The square root of a negative number doesn't have real solutions, so they're going to have two imaginary solutions, and we call them complex conjugate solutions. That means your graph doesn't have any x-intercepts. If you're taking the square root of 0, if your discriminant is 0, then imagine doing plus 0 minus 0. You're going to get the same number. Negative b plus 0 is negative b minus 0 is negative b. So you're just going to get one solution. What that's going to do, it's going to look like a bounce on the x-axis, so it's a double root. But if your discriminant is a positive number and you're taking the square root of a positive, just think about negative b plus or minus a positive. How about like 5 plus the square root of 2, 5 minus the square root of 2? Those are two distinct real solutions, and you're going to get two x-intercepts, okay? So a negative discriminant means no real solutions, two imaginary. The rare case of getting 0 means one real solution, double root, and then the positive discriminant means two real solutions. Okay, so this is written in standard form, ax squared plus bx plus c. I like to label these, so there's your a, there's your b, and there's your c. Or you can even label them off to the side. A is 2, B is 4, C is 9. Okay, that's almost even better because now if it's a negative number, you're not just pointing at the number, you actually got it written out there. So I would recommend writing them all out there. Now the discriminant, let's look at that. The discriminant like that. It's b squared minus 4ac. So our b is 4, so we get 4 squared minus 4 times a, which is 2, times c is 9. That gives us 16 minus 72, which gives us negative 56. Okay, so that's a negative number. So what's going to end up happening is we're going to have negative b plus or minus the square root of negative 56 all over 2a. I obviously haven't plugged in for b in 2a yet, but when the discriminant is negative, you're taking the square root of a negative, and that's imaginary. Okay, so you're going to have two complex conjugate solutions, okay? Which means also there's no real solutions. No real solutions. There's no x-intercepts that touch or cross the x-axis. Okay, now let's see if we can find those. The way we do that is we plug in. So first thing I do is I set it equal to 0. So I'm going to say 2x squared plus 4x plus 9, set it equal to 0. If it's not already an equation that we're solving, like on b, b is already an equation you're solving. If it's just the name of a function and it says to find the zeros, you got to set it equal to 0. All right, now we know what our a, b, and c are. Just to remind ourselves over here. I always write the formula down first. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And now it's just a matter of carefully dropping in. B is 4, so negative b is the opposite of 4, which is negative 4, plus or minus the square root of. We already found that to be negative 56. So if you were plugging it in for the first time without finding the discriminant, it's worth going off to the side and doing all this bench work because it clutters up the rest of the problem. And then all over 2a, that's 2 times 2, which is 4. Oops, I'm sorry, 2 times 2. I don't want to say 2 times 4. 2 times 2 is 4. A is 2. Okay, so now I simplify. Here's what I would do next. I would do negative 4 plus or minus. Because I have the square root of negative 56, I'm going to write that as the square root of 56, and I put an I on the outside. Remember, the square root of a negative number is the square root of the positive number times I. You're literally bringing the negative out from inside the radical and putting it as an I on the outside, and it's all over 4. Now I got to come back over here on my side to the workbench. I got to simplify 56. You could do a factor tree if you want, but I'm going to do upside down birthday cake or the ladder method. You start with your smallest prime, which is 2. It goes into 56, I know, because 56 is even. So that's 2. Half of 56 is 28. And then you keep going until you can't go anymore. Does 2 go into 28? Yes, it does. That leaves us a 14. 2 goes into 14. 7 times. 2 does not go into 7. Neither does 3, 4, 5, 6. 7 does because it's prime, and you get a 1. And the reason we call it upside down birthday cake is because now it looks like a birthday candle upside down. You can turn your monitor upside down, and it looks like a tiered birthday cake with a 1 candle at the top. Okay, so there it is. Now remember, it takes a pair on the inside to become 1 on the outside. So I'll write this. The square root of 56 should equal a 2 on the outside times the 2 and the 7 that don't pair up on the inside. That turns it into 2 times the square root of 14. So I bring that back into my projects and I get -4 plus or minus 2 square root of 14 times I, still on the outside, all over 4. All right, now to put it into a plus bi format, we have to split it up. Each term in the top gets the entire denominator. So we get -4 over 4 plus or minus 2 square root of 14 over 4, and I'll kick the I off to the side as a coefficient, as if it were an x. And now I simplify each term. -4 over 4, that's a -1. The 2 over 4 simplifies to a half, so I get the square root of 14 over 2 times I. And there they are. There's the two complex conjugate solutions, two complex conjugate solutions to the function. Ta-da! See? Piece of cake. Nothing to it. All right. We'll do B on the next example. That's it for this one. All right. Any questions? Email me at kcorpy at mbisd.org. I made a careless mistake somewhere going through there too. It happens. It definitely happens. I was scratching my head and patting my belly while I was doing this problem, and it's hard to do both of those, much less do a math problem and talk at the same time. So I'm pretty notorious for making careless mistakes. Email me, kcorpy at mbisd if I make one.org. All right, y'all have a great day. We'll see you on example B on the next